All right. Hello, everybody again. Welcome to our Karmada biweekly meeting. And today's meeting, the only thing on our agenda is idea of automatic API document generation. I've already opened this slide. I'm gonna hand it over to um, a fan. I think he's already in this meeting, and Jin Chao.
Yeah. Should I
Stop
share my?
sharing. Sure. Stop sharing.
Yeah. I hope that it is visible.
Yes, I
So
can see the screen.
today's agenda is to talk about the Karmada API documentation generation. So let me just full screen this. Okay. So I'm a mentee for LFX mentorship program, and I'm also a tech blogger. I write blogs about Kubernetes, DevOps, and AWS sort of stuff. And I also do freelancing part-time as a DevOps consultant. And I'm also an open source contributor and a student. So I am being mentored by the Zen Chang for this LFX mentorship program. And we are working on Karmada API documentation generation. So we have many tools to generate the documentation, like Swagger, CodeGen, Redocly, and here is the GenCID API reference docs, another open source tool, and Bootprint and Kubernetes reference docs generator. So a lot of tools there. Let's have a look at Redocly. Redocly is my personal favorite tool because it have a nice UI. As you can see on the screen, here are the query parameters for the API queries. And on the right side, here is an example for the request. And left side, you can see that here is a sidebar for navigation. So, but there is a problem with Redocly. Redocly generates a whole new website for documentation, so we can't embed that on the karmada.io. Although we can set routings based on URL, or we can use a subdomain like API docs.karmada.io, but that's not what we are looking for. We want the API documentation on the Karmada website. And the other tools also generate a single HTML file, but unfortunately, there is no native support for using HTML file in Docusaurus docs. Don't get me wrong, we can use the HTML file in the Docusaurus, but we can't use that in the documentation. Let me just open up a terminal real quick. So we can't use HTML in this docs folder. I believe you can see this. Or is it too small? So here is the docs folder where all the documentation is stored in the markdown format. So we can use the documentation in HTML format in the docs folder, but we can use this static folder for serving static HTML. Back to the slides. So there are no open source tools that align perfectly with our requirements that generate a markdown file. Most of them generate just a single HTML file. And we have also tried to convert the HTML files into markdown, but it didn't work out well. This converters doesn't do well. It generates just a broken markdown file with a broken format. So in this scenario, we decided to create our own documentation tool or script for generating documentation in the Markdown format. Let me show you the tool real quick. I shared a link in chat. So I decided to write my own script, and we also have a screenshot for that. So here is a screenshot from the documentation generated by the script. You can see uh, it is in the tabular format, and I believe we also have a preview somewhere on GitHub. Oops. Hmm. So for the moment, we just have this screenshot, uh, and let's move on to the next slide. So the problem with writing our own script is the maintenance. My mentor then told me that we would have to maybe maintain the script in the future, but I think the maintenance would be minimal. For example, if we decided to add a new API group in the Karmada, let's say we have decided to add storage.karmada.io. So in that case, would we have to change the script? Absolutely not. So in which case we would have to change the script. If the Swagger, if the schema of swagger.json changes, in that case, we would have to also modify the script. Let me just open up the another code editor. So here is the Swagger JSON file for the Karmada APIs. So if we add something like storage.karmada.io, we wouldn't need to modify the script. But if we try to migrate from the Swagger 2.0 to Swagger 3.0, in that case, we would have to modify the script or probably rewrite it because the schema would change. So these are the issues with writing our own script. So, uh, so Zen told me to find a way to embed the bootprint HTML in the docs. Bootprint is a tool for generating the HTML documentation based on the swagger.json. So we have generated some documentation with the help of Bootprint. So Zen created this PR. He came with the idea of React component to include the HTML in the Docusaurus. So here is the deploy preview. I have shared the link in the chat. So the problem with this deploy preview is that we don't have the whole documentation for the APIs, and the sidebar also looks some. It doesn't look very well. Sidebar is a little bit messed up. The This is happening because the HTML file is overriding the CSS of the Karmada, and the way uh, Zen embedded the HTML is he used a string. Where can I see this? So here we have tried to embed the HTML using a string, but that doesn't look good. But it's a good idea to use the React components. So thank you, Zen, for bringing the React components. The problem with this string is that if it's too big, the build would fail. So we have modified our method and created a new PR. Let me just share that in the chat. Yeah. So this is the complete API documentation here with a good looking sidebar and documentation with some nice CSS. But to implement this, we have did a little hack there. As you can see, we are using these React components, and here is the code. So here is the HTML. So basically, it is making an HTTP call to the slash docs and embedding the documentation on the client side. So it's basically client side rendering here. So what we have done is we have created two files, the docs.html and the main.css. And these files are generated by the Bootprint. Bootprint is a tool for generating HTML documentation. So these files are in the static folder, and
Hey, Hassan, sorry to interrupt you. I think you are on mute. I cannot hear you.
Hello, Afan. Are you trying to generate the docs now? Hello, Afan. We can hear you. Oh,
Yes. Can you hear me now?
yes.
Yes.
Yeah.
Yeah. So, uh, mm. So here we have the main.css file generated by the bootprint. And to fix this sidebar, we have added the main styles.css of karmada.io into this file. So the Karmada CSS overrides this HTML CSS. Let me just show you a demo of the bootprint. Mm. So here we have the swagger.json file, and if I run bootprint and with the parameter open API and the file name and the name of the output folder. So it have generated this folder here, and in this folder have these three files: index.html and main.css. Let's open up our code editor here. It's a bit confusing because I have multiple code editors open. Let me just close one of them. So here is the index.html file. We can copy this and paste it into the static folder of Karmada, right? And we'll do same with the CSS. So we have pasted the HTML file. Now let's paste the CSS. Copy the CSS and paste it here. Okay. So I believe that it should change now. Not this one.
Hello, Afan.
So
May
yeah,
I ask a question?
I think we have a problem here. The file seems to be broken here. I'm not sure why this is happening. Yes, yeah. I forgot a backslash here again. Add a backslash and refresh the page. Mhm. Hold on a second, guys. I can't reproduce this bug of the messed up sidebar at the moment, but we had that bug, and what we did is we copied this
Okay.
CSS.
I guess we can skip the bug, and we don't need to debug this is here, and continue your presentation.
So yeah, I can't produce the broken CSS bug, but we have found a way to fix that. So the next steps are to break down the documentation into multiple pages based on the API groups, like a separate page for cluster.karmada.io and a separate page for networking.karmada.io. And we will also need to create a CI pipeline to update the documentation. So
Okay. Mhm.
if you have
Uh,
any questions or suggestions, please share with us.
Thanks, Fine, for I know you invested so many tools. So finally, which tools you are selected? The bootprint, right?
Yes, so we decided to move forward with Bootprint. But if you have a
Bootprint.
suggestion, uh,
Okay. Can you go back the last slide? Yeah, slide 12. Yes. I am not sure if it's easy to create a CI pipeline for updating the things, because the API is managed in Karmada repo, and the website the documentation will be in website repo.
yes, I understand that we can use some credentials for our CI bot that can access the both repos. And if the Swagger JSON gets updated, the CI bot will run the CI and add a commit to another repository. We might have to use some GitHub access tokens to do that. Maybe we'll figure that out. But that's possible to create a CI pipeline like that.
I think if we can have a for example, have a some scripts, we can use the scripts to manually updating the documents, and after that we can consider to create a CI pipeline.
Yeah, that's a good idea. In a first few days, we will manually update the CI. Oh,
Yes.
sorry, manual documentation. Then we'll write the CI scripts.
Yes. I think it might be too much evolved to create the CI pipeline for now.
Yeah, we are more focused on the documentation itself because we also have to split that up into multiple pages.
Yeah.
Anything else?
No question from me now. Hello, Mike. Do you have any suggestions for generating the API things?
No, I think this is great. We are also looking for something similar to this, but I was really hoping that it's not like a custom script, but a more common use tool. but that's okay. I will look into this and see if it's something that that's quite useful. Yeah. Thank you. Thank you, Afran. Thank you, Hong.
Hi.
Hi.
Hi. Hi, this is Yao from Bloomberg. Yeah, it's we are looking for class Kubernetes Federation API or management tool. So we met Kevin in the KubeCon European. So and now we're trying to try out Karmada on our internal Kubernetes based clusters. So I have a few questions. I also bring the issues to the upstream. So the first question is like to support extended resource like GPU. I remember you mentioned the fragmentation. There's still like fragmentation issue for the resource, like GPU resource. Do you have a plan to fix that and also include the extended resource in the resource model?
Yeah, thanks, Yao. I would say I see your issues on Karmada repo, and they are still in my coin, you know. I'm basing currently I'm preparing the KubeCon China stuff, so it's a little bit delayed. But yeah, I think it's a yeah, as I talked to you in the issue for the GPU thing, I think Karmada should do something to support the AI areas workload. So we should do something to support this better, but I don't have a detailed idea for now.
So
Yeah.
can you explain a little bit like what makes it's like a bit different than the CPU and memory, like those resource compared with GPU support?
You are talking about another issue, right?
No, it's more like how we support GPU in resource model. And so currently we can use that, but there is the GPU fragmentation issue as you pointed out, right? In the current framework, because you're in the resource resource model, I see like the default one you use it as an exponential model, like you have different grade that only for CPU and memory. My question is like why it make different between the GPU and the other resource, why we like include that GPU in the resource model.
Sorry,
So the first question is like, why not include GPU like in the resource model? In the resource model, it only supports CPU, memory, ephemeral storage, and I forget there's another one. That's my first question. The second question is like, so currently, if we use Karmada to schedule job with GPU, we have this GPU fragmentation issue. Like how could we resolve that? Yeah.
Okay. Got it.
I still have the last question is like, I see your resource model, you use the default one is like the exponential one. You have the different grade until grade 8. It's like with two, it's more like exponential model. But the question is like, do you have any statistical analysis like why you choose this algorithm? Like when you choose this model as a default one, how the fragmentation issue is resolved? Like, do you still observe those fragmentation issue, or like, we'll say like 85% of this fragment issue is resolved? So for example, you submit 1,000 job for a particular size of your cluster, and when applied to this resource model, like, do you still see some job still scheduled but in pending state, but caused by this resource fragmentation issue? Like, do you have those analysis? Like, and then why do you choose this resource model algorithm?
Yeah, the third question you're asking, why we are using that research model at the default time, right?
Yeah, as a default one, because I can explain our situation. We are not public cloud. We are like private. You can think it's a private cloud, and our cluster is pretty small. I can say there's at most 100 nodes, maybe even less than that, like maybe only 50 nodes per cluster, and we only have like 2 or 3 clusters per tier. Is for us, it's more like we can have those node information saved or cached in the tier level, like in the Karmada level. Then if we have all the node information, like for the size of the cluster we manage, then we don't need to use any resource model, right, to solve this problem. I guess you introduced this model because it's more like managed cloud. You're like public cloud. You have like tons of thousands clusters. You have to use this model to save, like to save your resource, like to do this calculation, right? But in our case, it's not hard, like to catch all the node information.
Okay.
Yeah, maybe we can divide the question like into several parts. So the first one is like how is that easy to include resource extended resource, especially GPU, in the resource model? And then the second question is like, how could we resolve the GPU resource fragmentation issue? And the third question from us is like, if you guys can have any analysis result to show how the default how the default resource model can help resolve the resource fragmentation issue. And then we also need you guys some suggestion, like how could we customize our resource model in the case like we manage like very small clusters. That's like 4 questions.
Okay.
Is that possible, like to discuss that offline, or like I know you guys are preparing the China KubeCon. We are not that like urgent, but we still want this question to be solved because most of our workload is like the training workload. We use the Kubeflow, as I mentioned. Yeah.
I would say we are always love to help users to be to start to investigating or start using Karmada. I'm not sure I'm the right person to answer your questions, so I can answer some in general, but can you please put your question on the issue, and
Okay.
I can ask the resource model author to comment on that.
Yeah, that would be great. Yeah.
Yeah, for the first question, I think we can extend the resource model to support GPU resource, but I need to look into the code and see how we can do it for because the resource model now is now used by the Karmada scheduler. I need to figure out how much effort we need for that. And for the another question you asked why we use that research model as the default one. I think it's just the default model might not suit for your case. Then you can define a model for your case, as I guess.
Yeah, so that's part I need some guidance or suggestion from your side, because I can provide more details like how of our scale, the scale of our problem or our cluster. I really need you guys' help for this one.
Okay, for this question, I can ask the author to comment on that on the issue. Okay.
And that, we also have another. Yeah, this is more like resource model question. I can put that those questions in the issue. Maybe you can help to find the author of person to help us. Another question is like I see you guys support federated resource quota. It's still like in the experiment stage, but I see like you guys are explore the federated resource quota. But is there any plan to support a global resource quota instead of federated one? Yeah.
Actually, we are waiting for more feedbacks on the resource quota thing, including what exactly the use case we need to support. So we are glad to hear more feedback from you So feel free to open, for example, open an issue on the GitHub and describe your use case there.
Okay.
Okay. Another thing, I think please feel free to, for example, add an agenda to next meeting. So before the meeting, I can try to invite related maintainers here, and we can have a quick chat here.
Yeah, that would be great. I will put that in my question in the agenda, and also put a question in the issues. Maybe we can discuss offline. Yeah.
Okay. Thank you.
Yeah, thank you very much. Yeah. Will you guys come to KubeCon Chicago in November this year, or?
I'm not going, but Ying might be there.
Oh, okay. Maybe we can catch up, also catch up in the KubeCon Chicago. Yeah.
Yeah, I think Transy and myself will be in the KubeCon American in Chicago. I think early November. But we don't have a Karmada booth. We only have a 45-minute speech regarding the HPA across multiple clusters using Karmada. Yeah, I'll be sharing the link later in the chat.
Okay.
But
that would be great. Yeah.
Awesome. Any other questions from you or any other audience? Guessing this silence is a no. And thanks again, Fan, for your presentation on the API documentation. And thanks to everyone for participating in this meeting. And I will see you next time in 2 weeks. Yep.
Yeah. Thank you very much.
Bye, everybody. Yeah. Have a wonderful rest of your day. Bye, Hongzai.
Bye.
Bye.
Yeah, bye.